covariance of x comma y is sensitive to the units. Let me write some more thing. Covariance of normally is going to show the direction is greater than 0. I can assume if things are proper, I can assume positive direction. But this is not working very well. This how they developed this, but still it is having its own loophole. Negative direction and covariance of x comma y is 0 means what? This is a wrong statement. This is wrong mathematically. But you can take it. What is the meaning of this? Covariance of x comma y 0 doesn't mean that they are independent. But if they are independent, definitely covariance of x comma y will become 0. All with me? Covariance of x comma y 0 doesn't mean that they are independent. But if they are independent, pakka covariance vice versa is not true. I mean, covariance of x comma y is 0 doesn't mean that they are independent. But for practical purpose, I'll take it as independent, not a problem. Okay? Why it is happening and all? If time permits, I'll discuss. Otherwise, I'll ignore. Just take it as a blanket statement. Is that fine? So these kind of issues we teach in higher end course. For example, if you join the probability course, at the time we'll deal these kind of things. You guys are getting? Because it takes its own sweet time. So, but what I'm saying is vice versa is not true. Independent means covariance of x comma y is 0, but covariance x comma y 0 doesn't mean that they are independent. If the statement is clear, but we are going to deal the data such that those will become independent. So why I need to learn? You guys are getting? I'm going to exploit that. Okay. What else? Let's go back to our previous derivation. I said there this thing, right? I ignored the proof. Proof करेंगे, then we will get into the rest. Is that fine? So proof for variance of x plus r minus y equal to variance of x plus variance of y plus r minus 2 times of covariance x comma. You guys remember, anybody heard about something like dimensionality reduction, all those things? Big data analytics. I need to reduce the dimensional. It's only going to work there. Of course, we'll learn all the things at the time. But just I'm giving a why I'm learning, the reason for learning. How both are independent? What she's saying, call center data 0 to 1 hour and 1 to 2 hours are independent. Are they independent? For example, there is a disruption. Definitely, if 0 to 1 hour, if I am receiving the more number of calls, definitely I am going to receive the more number of calls in the next 1 hour. Are you getting what I am saying? Everything is going fine on 0 to 1. Definitely I may receive 1 to 2 may receive the same way, 0 number of calls. They are dependent. You guys are getting? If 0 to 1 number of calls are increasing automatically, 1 to 2 number of calls also going to increase. You guys are getting? Sorry, but that is clear. So they are independent. If one is increasing, automatically another increases. No? Common sense, guys. Okay, I'll come back. Those kind of things afterwards. But variance of x plus y, x plus r minus y equal to variance of x plus y, so y plus 2 times of covariance of x. Proof. We know what is that? Variance of x equal to E of x square minus E of x whole square. Agreed? Now I'm going to write the same. I don't know whether I'm going to get the result or not. Let me try it. I'm taking only x plus r plus y. Is that fine for our consumption? E of x plus y whole square minus E of x plus y whole square. Emandi, you guys want the proofs or not? Without proof also I can teach, not a problem. But if you know the proof, you are more confident about the subject, right? You should be violent with the confidence. That's how you need to learn the subject. Karo, expand karo, inside. X square plus y square plus 2xy minus E of x plus E of y whole square. Agree? Emandi. I can apply this E of x square. I can multiply, right? 2 times of E of xy. E of xy is not equal to E of x into E of y. What is the meaning of that? Multiply the two numbers, take the average, is not equal to multiplication of the individual averages, right? Yes or no? That will become, that also become equal when x and y are independent. We'll see that. We'll see that again. Minus this, I'm expanding a plus b whole square. This means E of x whole square plus E of y whole square plus 2 times of E of x into E of y. Emandi. So now I'm writing like this. This and this together I'm writing. Can I? What I'm saying is this. I got the result. Similarly, because I know these results, right? Minus, I'm not taking 2, I'm taking here, E of xy. Let me write it and I will explain. E of x no, this is minus 1. Can I explain? I've taken these two terms, I've written here. I've taken these two terms, I've written here. I've taken this and this. I need to multiply minus inside, right? 2 I've taken out, E of xy, that is from here. Any question on this? Any question on this? So this equals to variance of x, first one, already we learned, plus variance of y, second one. What is this? Already yesterday we learned. Covariance of x comma y. So 2 times of covariance of x comma y. Proved. Hence the result. Even you do for minus also, you are going to get plus only. Convinced? If you know the proof, no need to remember the formula. Right? Friends, any question on this proof? Any question? So yesterday we proved covariance of x comma y equal to 0, which implies I can write covariance of x comma y as like this also. So if this means E of x comma y might equal to, this is another condition to verify the random variables are independent or dependent, right? You guys are getting? Calculate the E of, so what I'm trying to say is this one. Calculate the E of x, calculate the E of y. What I'm trying to say is this. Anyway, copy. I'm going back to the original form, not in minutes, in hours. Okay. So what I'm trying to say, if this is 0 near to 0, E of x y equal to E of x into E of y, then I say that they're independent. But let's not worry too much about this independence or dependence for the time being. We are going to learn some other techniques where you understand better. You guys are clear? But one thing you need to remember, if covariance of x comma y is 0, for practical use, you can assume that x and y are independent. Is that is fine, guys? Online? Is that is fine, friends? Any question before I move further? So far, any question? People stop asking now. Huh? No one is asking questions. This is a problem. When I'm teaching the box class, people jump left and right. When I'm teaching the actual important concept, nobody asks anything. Huh? Next. So as I told you, the covariance of x comma y going to depend on the units. I'm not interested in such kind of measure. I'm interested in something which is independent of units and which will tell me how the data. You guys are getting what I'm saying? That is correlation. What is that? Correlation. What is this correlation? Correlation, sample and population. Sample, this is represented by R, this is represented by rho, RH rho. Okay, let us calculate. I'm writing for the sample, sigma x minus x bar, y minus y bar by standard deviation of x. S stands for the standard deviation, right? And standard deviation of y. Clear? I think wait. 1 by n minus 1. Okay, 1 by n minus 1, that's the formula. Which means, if you look at, can I write like this? 1 by n minus 1 sigma x minus x bar y minus y bar by, what is standard deviation? एक काम करेंगे हम, learn first the population, then I'll come back and I'll explain this. So things will become easier. Rho equals to covariance of x comma y divided by variance of x into variance of y. Okay, not okay. There's a formula. How? Just take it as it is. Just take it as it is. I'll explain the why, the reason it is happening like this. We'll talk in the future. Okay? We'll talk why the formula is like this in the future. Even I explain, you don't understand. So covariance of x comma y by variance of x into variance of y. This is the formula. Let us simplify this. I am substituting the 1 by n sigma x minus mu x. Covariance is that, right? Y minus mu y divided by, what is the variance of x? Mu whole square, mu x whole square, n sigma y minus mu y by n. Agree? So this n 1 by root n, 1 by root n. What is that? 1 by root n into 1 by root n, 1 by n only. So this 1 by n I am taking out. Is that okay? Correct. Sigma x minus mu x and y minus mu y divided by 1 by n into sigma x minus mu x whole square into sigma y minus mu y whole square. This get cancelled. So what I'm trying to say here is, even for the population or sample, is the degrees of freedom. Even for the sample also, it is going to get cancelled. 1 by n minus 1, 1 by n minus 1. You guys are getting what I'm saying? Even you use n or n minus 1, it doesn't matter, right? Because anyway, it is going to get cancelled. Only the thing is, if you are using the population data or the sample data. If it is a sample, what I need to write? R equal to sigma x minus x bar whole square, sigma here, into, agree? Amen. You guys are clear? There is a sample, there is a population. So it is not going to depend on n, size n. Clear? So that's the reason. If you go and see in the Excel sheet, dot p, dot s, both are going to be the same. Because 1 by n or 1 by n minus is getting cancelled. Huh? Even I take the for sample, those will get cancelled like the way it happened in population formula. So this is for sample. Why sample? I am substituting the sample averages. This is for population because I am substituting the mu y. Clear, Sampath? If that is clear? So what are two different formulas? Sample and population. Here it is R, here it is the sigma. What is the formula? Sigma x minus x bar, y minus y bar by root of sigma x minus x bar whole square, sigma y minus y bar whole square. Agree? What about here? minus x square sigma y minus. So can I replace in shortcut? Let sxy equal to sigma x minus x bar. Because I am writing for the sample. You guys are getting? What is my sxx? I need to substitute this. That will become this. Yes or no? What is that? X minus x bar square sigma. What is s by y? So in simple way, rho equal to sxy by root of agree? Emandi. This we write as Rx comma y between x and y variables. Any challenge? Guys, any challenge? Now let us understand what about x comma x? What this will become? X comma x divided by x. This is also again x comma x. This will become how much? 1. R equal to 1 means what? X and Y very strongly related. If the value of x r equals to 1, what I am going to say? They are strongly related. X and x itself, my friends, they are strongly related. M and D. It is going to be depend on one another, no? X comma y x. If you plot x comma x, what is going to happen? It is going to be a straight line. They are going to fall on one line, right? Positively related. You guys are understanding this point, friends? 2 plus 1 is the maximum value. Maybe if it is negative, how much negative I can have? X comma minus x. I mean, x and x both are negatively related. One is increasing strongly. So it can be minus 1. And if this is not related means what? The numerator will become 0. Covariance of x comma y is 0. So this will become 0. So this is what I am trying to say is the correlation value is going to fall anywhere between minus 1 to plus 1. You guys are getting? And which is independent of units. And R is independent of units. R is independent of units. What does it mean? Why it is happening? Let us verify that. What is the formula? Covariance of x comma y divided by sxx. Stop sxx. Sxy divided by, right? What are the units for this sxx? Let us go and understand. For example, this one and this one. This is a height and weight. Height multiplied by weight. What I am going to get? The numerator units. Height meters and kg. M and D numerator. You guys are getting? And niche. What are the things? Root of, I am squaring what? Meter square? Meter square. Here, kg square. So what is happening? Meter into kg divided by meter into kg. Getting cancelled. 1. So R is independent of units or not? So R is independent of units. Okay. If R equal to +1, what am I going to say? Positively related? Why positively related I am talking? Let us understand this. This denominator anyway positive, right? This denominator anyway positive, right? Only ऊपर का क्या है? Covariance of x comma y. If that is positive, I am going to get R is positive. If that is negative, I am going to get R is negative. If that is 0, anyway, no relation. Makes sense? Makes sense, guys? So whatever the interpretation we learn in covariance of x comma y, it is going to cascading down. All are with me? So what I am saying is R equal to +1, positively related, negatively related, and R equal to 0. What I can say for our practical purpose? Independent? Friends, all the things are clear or not? अभी हम calculate करेंगे. What is the covariance formula? Correlation, sorry. Correlation. Covariance of x comma y. Yes or no? Covariance of x comma y already I calculated. Divided by square root of variance of x. SQRT of variance of x. Where is that? Is it there? Variance of x is there, but is what about the variance of it? It's not there, no? Let us calculate. Where is there? That's fine. Again, I'll do it. No, I need an individual, no? Denominator, separate. Variance of, I can use this. I'm using the, if I'm using the dot P, numerator and denominator, you need to use the same. Because before calculation in the previous class, we have done for dot P. I'm doing the dot P. Is that clear or not? This one? This is the variance. What about this? Let me calculate one more time because I cannot trust my calculations. Last verification, let me do one more time. I can use variance of dot P of x, right? See? Both are same? Yeah, both are same. Not a problem. Now, what is the correlation? Already we calculated using the formula. Let us calculate covariance of x comma y. That is this. Yes or no? Or that is this. Both are same. Divided by square root of what? Variance of x. That is this. Multiplied by square root. Again, I can multiply both the square. Root a into root b equals to root ab. So I can multiply both inside. Something wrong? What is that? Fine, right? Yeah. So how much is this? Minus 0.21. Okay. Now let's change the units. Is it going to change or not? Let's verify now. I'm going to change the units. We'll interpret this number afterwards, but understand, is it going to depend on into 60 minutes? That's what we have done. It's happening. Something wrong? Is it happening or not? Not happening. What's the problem with my Excel? M perfect now. Anyway, I'll do this. Okay. And this, again, this multiplied by 60 minutes. Why it's not coming out? I've done something to my Excel. Okay. What I've done? Variance of X, variance of Y should not change. Some formula problem. 1 minute. R7 is fine. The variance of X. I've done some mistake somewhere. This covariance of X, covariance of Y, variance of Y. Somewhere I have screwed up the calculations. Wait. Covariance of X comma Y. Covariance of X comma right. Here I am getting the positive number. I don't know, some mistake. You guys are getting? Yeah. And variance of X is variance of dot P. What it is? Variance of what is that? Variance of I? Variance dot P. Okay. Now let's calculate the correlation. This divided by square root of this multiplied by this. Sorry? SQRT. Okay? Now I am copying this backside without you changing the units. I mean, I'm taking hours. Same? You guys understood this? So, irrespective of the units, I'm going to get the same correlation. So, what is the interpretation of this? They're not independent. The little bit of negative correlation is there. You guys are getting? So, what I'm trying to say, by looking at the graph, I assume those are independent, right? But when I really calculate it, it is giving a little bit of negative relationship. So it is coming like this. You guys understood, guys? Friends? You guys understood? Online? So instead of doing all these calculations, I can use a function also. What is that function? Correlation. Correlation. I need to give the, there is no dot P dot S, right? Both are going to be the same. Comma. But you only come to know whether you are doing for the sample data or the population data. If you are using the population data, that will become the mu x. Otherwise, it will become a x bar. Excel doesn't know. You guys are getting? Both are same. I use the function name here. So, like this in R and Python, you are going to find this kind of function. What is there to teach in R? You hate it, I am telling you. Once you know that with a paper pen, what is there to teach? Hope you guys are understanding the importance of R or Python or whatever it is. Just those are the calculators. But you need to understand all these dynamics, how the things are happening. Okay? Abhi, let me show the same thing using the Minitab. Abhi karu. Okay? Basic statistics, covariance, how much is that? Same, whatever we calculated. Okay, not okay. Similarly, covariance also. This is, let us understand this a little bit. What is the XX covariance? This is the, this value is what? X and X covariance, right? That is nothing but what? Covariance of X comma X is what? Variance of X. Even you guys are understanding. So he is giving me a matrix format, 2x2 matrix. So this value is what? Covariance of, this is, whatever this, covariance of X comma Y. So this is nothing but the variance of Y. This is nothing but the variance of X. You can verify. Either 366 and 859. Okay? Why he is publishing here? Why that people may ask? Why that difference? Variance of .s you do it. Same. So what Minitab is publishing? Sample variance. All are with me, guys. So why the difference? Because dividing by n or n minus 1. So that is the difference you are getting it. You guys are clear? Friends, why to use the correlation when the same can be achieved by with covariance? Can I get the same thing using the covariance? Because based on the change in the unit, the covariance value is going to change. I'm into confusion, right? Are you clear, guys? Spurti. Okay? Now. That's fine. He is saying that, if X is there in, I'm taking height in centimeters. Another, let's take the real estate house, cost of a house I want to do it. Okay, height of the building, SFT, height in maybe in meters, SFT in the area in maybe SFT. Take it, no problem. But the covariance is going to get impacted. Correlation, it is not going to get impacted. All clear? Okay, something I am missing. What is that missing? Something I am missing. So in summary, so far what we learned? Let me recap the ideas. We learned how to identify the outliers, right? Using a box plot. After that, we moved to different graphs. We understood what is the line chart, what is the bar chart, what is the histogram. In that, we talked a little bit more about the histogram, because histogram is going to provide a lot of information. Range of the data, spread of the data. Yes or no? Characterizing the data. Okay. After that, we learned what is the random variables. And in that, we understood what is a continuous, what is a discrete. Okay. And then what we learn? E of x. We move to the central tendency. In that we learn mean, mode, median. And we define expected value of x, which is nothing but the mu. And again we learn variance, spread of the data. We move to the spread of the data. In the spread of the data, we learn variance, IQR, range, and standard deviation variance. And we learn different forms of the variance. But let me explain. I said, what is the meaning of the mean? Whatever it is happening most number of the times, that is a mean, right? What about the standard deviation? What is the meaning of that? How can I interpret standard deviation? Standard deviation is nothing but the consistency. More consistency means what? It is always attacking on the center. For example, let me give you an example so that you guys understand what I am trying to say. How these two are related, mean and standard deviation. Let's say there are two cricketers. Okay, one cricketer is making runs 0, sometimes 200, sometimes 100, again 0, sometimes 10, like this. And on average, let's say when I take the average, he is 50. You guys are getting? On an average, how many runs he is making per match? 50 runs. Now another person, he is doing like this: 50, 51, 49, 50, like that. Still, when I have taken the average of that person, still he is getting same. Which one you want to recruit for the coming match? First one or second one? Second one. Why? He is more consistent. If you go and calculate the standard deviation, what I'm going to get? Average is going to be 50. How much is deviating from the center? +1 this side and -1 that side. Yes or no? So the consistency is more. But what about in the first case? Consistency is less. Sometimes he is making 0 runs. Sometimes he is making 100 also, 200 also. You guys are getting what I'm trying to say? So what I'm trying to say is standard deviation more about the consistency. Mean is more about the repetition. He is able to repeat it the same way more number of times. You guys are clear? Most frequently occurring, right? All are with me, guys? We always use correlation. No need to use the covariance, enemy specific area. You don't worry about all the application. We are going to see all those things. But for the timing, you take it correlation. If I use the covariance, what are the issues I am going to get? If I use the correlation, what are the advantages I am going to get? We are going to explore all those things in the future. Okay? We are calculating the covariance to calculate the correlation. You have seen it. Why you are asking that? You are not important. Mean. Instead of mean, let me talk as a central tendency. Is more about what? It's not going to be about consistency. Repetition. Most of the times, what is happening? Yes or no? Most of the times, what is happening? And variance or standard deviation? Standard deviation or the variance, both same only. It is talking about what? See, average is a misleading. Why it is a misleading? Let me tell you. Okay. Why it is a misleading? Let me explain. Let's say there is a manufacturer, he wants to buy some goods from another manufacturer. Okay? Or one client is there, one customer is there, he wants to buy from a company some goods. He's sending the defective goods. He is sending the goods in a lots. Lot means what? In boxes. Okay. So at the time of the agreement, what manufacturer said, on an average, I may send 2 defective items per batch. How many? 2 defective items. For example, let's assume each box is having 10 items. When I go and sample it, I'll get the 2 defective items. Up to that, there is a possibility. I am not going to give more than 2 defective items. These are things are clear. What I said, on an average, I'm going to give 2 defective items. So the average of 2 can be achieved like this. First, 0 defective box. Second, 0 defective box. Third, 0 defective box. In the fourth box, I'll give 6 defective box. Still, if you take the average, 0 plus 0 plus 0 plus 6 by how much? 4? Less than 2? But fourth box is having a problem? Yes or no? But when you look at the consistency, that is the standard deviation, average is how much? 0 plus 0 plus 0, but 6 divided by 4. Or take that as a 8. Instead of 6, take 8 for our simplification. 2 defectives, 0 plus 0 plus 0 plus 8 divided by 4. How much is that? 2 defectives. How much each one is deviating? 2 minus 0 whole square plus 2 minus 0 whole square plus 2 minus 0 whole square plus 2 minus 8 whole square. Very large it will become. You guys are understand? Are you going to have a deal with him? So normally, most of the times, these are mistakes people do. They talk only about the averages. They don't talk about the standard deviation. But if you ask me personally, standard deviation is more important than average. All with me. For example, there is a BPO or there is some BPO non-voice company or maybe production support. You need to fix 10 problem tickets per day. Today, 0 problem tickets I fixed. Tomorrow, again 0 problem tickets I fixed. But next day, I'm going to fix 30. If you look at 0 plus 0 plus 30 divided by 3, still 10. But it is a misleading, right? So always you look at mean in the context of standard deviation. Then only it makes sense. Otherwise, it doesn't make sense. All are with me? All are with me, guys? So whenever I'm talking about the standard deviation, you should not recall the formula first. You should recall the consistency word first. After that, you should recall formula. All clear? So what I'm saying is standard deviation and mean both should be analyzed together. Standard deviation high, for example, a cricketer is making runs, on an average is making 100 runs, doesn't mean that every match is making 100 runs. The average run rate per over, 6 is the run rate per over. Does it mean every over they made 6 runs? Few overs they might have made 0 runs, right? Does it mean it is a more good bowler or bad bowler?